Hello, I'm Connor Looper, and we are Group 9. We were tasked with creating a structural design for a three-story urgent care building in Bloomsburg, PA. For our design, we went with a simply connected steel frame building.
At the beginning of the semester, the architecture drawing of the building is provided to the group. Then the group calculated the load on the building based on ASE 722. The E-test model is developed based on the structure drawing with proposed modification, and the loads are applied to the model for structural analysis to get the preliminary sizing of the structural members. In addition, iteration will be performed based on the results from E-tests to refine the size such as serviceability and deflection. The group used simple connected structural system for the project because of the simplicity of designing and better performance under seismic load affections. According to ASC 722, the building will need to withstand dead load, life load, snow load, wind load, and seismic load. The controlling load combination will be 1.2 dead load plus 1.6 life loads plus 0.3 snow load.
Here's a plan view of our floors 2 and 3, and you can see the layout and dimensions of our beams, as well as our concrete slab location. Here's our west wall elevation view. You can see some of our cross bracing, our column location, and the floor heights.
The wind loads were calculated and applied to the largest side of the building in order to find the lateral forces. This can be seen in case 1 and case 2 from an east side view.
For our beam girder connections, we used 3 by 3 by 1/4 L shapes and 7/8 Group 120 steel bolts. For our beam column connections, we used 4 by 4 by 1/8 or by 1/12 L shapes and 7/8 inch Group 120 steel bolts.
Cross bracing was added to the building in order to withstand lateral forces produced by wind loads and seismic loads. The bracing was designed based on tension and compression requirements. It is connected to the beam and column through a gusset plate and fillet welds.
Column splice will be designed based on ASC table 14-3 to ensure safety and stability during erection of the column. We only assume 50% of the load will be carried by the plate since only axial load is involved.
Our footing is 9 feet by 9 feet and 22 inches thick. And for reinforcement, we have 8 number 7 bars spaced at 14 inches, and that goes both ways.
The column is connected to the foundation through a 22-inch by 14-inch base plate using grade 36 anchor rods and fillet welds.
For sustainability, we'll add solar panels on the roof to reduce carbon footprints and electricity consumptions and increase energy efficiency.